Brilliant. Well, thanks very much for having me today. I feel very honoured to be here and speak to you all. What I'm going to just try and do this morning is, I suppose, provide a little bit of context for a bit of what we've done today, yesterday, tomorrow, and what I've called the journey of closed-loop plastics recycling, and talk a little bit about the journey that I and the team I'm working with have been on, trying to close some of the loop, and a particular process that we've been looking at that I'm going to use illustratively. Someone said to me once that in this game there are no silver bullets, only rusty ones. And our job as researchers and innovators is to polish up those rusty bullets and get them as good as possible. And I suppose that's what I feel like we've been doing for a number of years in the group I'm in, working in many times industrial processes that were developed long ago, technologies like pyrolysis, technologies like depolymerization that have been around for many years, but really trying to hone some of the challenges, some of the limitations, some of the environmental impacts and side impacts, some of the business challenges, integration challenges, and the new challenges that have opened up and the new opportunities that have opened up around digitalization and things like that. And so that's really what I'm hoping to try and do today, to try and illustrate, if you like, and contextualize what people later on today will do a much better job of delving into in detail some of those supply flows. But before I do that, I just thought I'd provide a little bit of context to where I'm coming from, some of the work we've been doing, and the Tees Valley region. So I'm working in the Tees Valley region, and you might not know where Teesside is. Teesside's in the northeast of England, sort of in between York and Newcastle, sort of in the middle of that. Teesside itself is a heavy industrial cluster, big history, polymer processing and things like that, but it's also undergoing a real green transition. It's a really exciting place to be. The government's very committed to the Tees Valley region, both economically and socially, but also in terms of this green transition. We used to have a very large steelworks there, that closed. It's now Europe's largest redevelopment site, and there's huge investment going into really creating a green future for the Tees Valley. We already create 50% of the UK's hydrogen. There are 5 new hydrogen plants planned for the Tees Valley. We've got the East Coast Cluster decarbonisation project, which will go in there, seeing between Hull and the Tees Valley region offshore geological CO2 storage and other CO2 generation projects going in. And also, and this is probably the most interesting for me, it has the highest concentration of non-mechanical recyclers in Europe. So many businesses that have been sponsored by Innovate UK, like RenewELP, Poseidon, RenewELP, Poseidon, Biffa have their advanced sorting capability there. DuPont Asian Film have a research capability there. Mitsubishi Chemicals are doing chemical recycling there. I could carry on Stuff for Life, which I'll talk about in a little while, have based themselves there. And obviously it's where CPI, the Centre for Process Innovation, one of the government's high-value manufacturing catapults for chemistry, is based out of, and many businesses have scaled up and innovated through the Tees Valley region around non-mechanical chemical recycling. And interestingly, today's the day that the Tees Valley cluster plan will release. Probably around lunchtime, that's when these things always seem to release, don't they? So you can read it on your lunch break. The cluster plan will release, and it will announce that the vision for the Tees Valley is to be net zero by 2040, and it will set out a roadmap about how it's going to achieve that. It's an ambitious target. It's heavily underpinned by these carbon capture and decarbonisation opportunities. And to resource all that, we've been very kindly funded by a mixture of ERDF, government, and the Research England Development Fund to build a centre specifically around this transition to really underpin the innovation of that. And I lead, in that line there, the Circular Economy Centre. And out of that Circular Economy Centre, we run our NZIIC Centre, the Centre for Circular Economy, Research and Innovation. And that's been running for a number of years in partnership with TWI. I coordinate that centre, and it has 5 major themes. Working with the bioeconomy, that's a big aspect actually up in the Tees Valley. Lots of heavy biomanufacturing companies like Fujifilm, Diasynth and others. Again, CPI have a biologics manufacturing upscale facility. We have a specialist research facility around biomanufacturing, which covers everything from soil science to drug development and things like that. Really interesting upscale opportunity there. We do a lot of work in this solid waste thing. I'm not really talking about it today, but I'll allude to it a couple of times. But 2/3 of what goes to landfill in the UK, and actually for that matter in Europe as well, is these solid wastes, mine tailings, things like that. Now, some of it's just top dressing, it's not so much of a problem, but large quantities of it actually are pretty challenging. They can classify as hazardous wastes, so anything between 120, 140 pounds a tonne to dispose of. These are major challenges to many developments, and so addressing this challenge, getting value out of these solid wastes, is a real opportunity and challenge. Pyrolysis technologies, we've got a whole group that work in pyrolysis, particularly around char. Again, I'll allude to that a bit later, including supercritical pyrolysis. We've got induction heated supercritical pyrolysis, so we can ramp that up really quickly. And polymer recycling, which is my main area, and I'll talk about mainly today. And all of that underpinned with this industrial digitalisation piece. We've got a strong partnership with Siemens around that, and again, I'm going to talk a little bit about that today, with how it relates to some of the trade and supply chain opportunities that relate to polymer processing. So, that gives you a bit about us, what we're doing in the Teesside region. So I said I wanted to talk through this idea of a journey. And actually, I'm going to use a graphic developed by this company, Stuff for Life. You might have seen them, you might not. I'll talk about their partnership in just a minute, but they're a really interesting company, but it doesn't half help when one of your directors also happens to be a leading communication specialist in the sustainability sector. So, you know, their marketing materials is excellent. But this wheel, you'll have seen lots of wheels like it, some slightly different, some linear, all sorts of things, is their model for what their circular process, which I'll describe to you as we go through today, looks like a bit. They start with use, return, reprocessing, remanufacture and supply. And they are proposing that this is the wheel. And there are lots of different wheels we could talk our way around, lots of different stages, but this is the one I'm going to use to sort of frame what I'm going to talk through today, this journey, if you like, working around all the way from use back to use again and fully closing the loop, and some of the stages we've taken, some of the learning we've taken in fully closing the loop and going product to product. So, let me tell you what that product is. Stuff for Life have a number of branches, but the one I'm going to focus on today is this. It's a partnership they have with Arco. And Arco, you may or may not be aware of Arco, but you've almost certainly worn some of their stuff because they make most of the UK's high-vis. So high-vis jackets, helmets, protective trousers, high-vis overcoats, all those sort of things they make and supply. Now, the traditional way of buying that stuff is you buy a 50-pack of vests, you use those vests, and then they go up a chimney. That's the traditional business model. So Arco have been with Stuff for Life and Teesside developing an alternative product as a service model to supply that. So in this new business model, what they're really offering is safety as a service. So rather than buying a 50-pack of vests, using them and then burning them, the new business model is you say, I've got 1,000 employees that operate in these environments, provide me safety. And Arco will provide a service contract to provide safety to those workers, the relevant high-vis, relevant protective equipment, etc. Now that works for a number of reasons. One is because high-vis isn't just something you put on and that's it. There are quite a lot of regulations around high-vis. So for example, you can only wash it 25 times. If it loses too much of its reflectivity, it doesn't meet the standard anymore, etc., etc. So there's a whole number of things, because this isn't just about making sure you keep people warm. This is fundamentally about your insurance liability and keeping your workers safe. It's a hugely important thing, and so to be able to offer that as a service is very valuable to customers. So what they do now is you can buy this safety as a service. They provide you with the relevant amount of workwear, and when you've used it, they provide bins, and you say, right, this is too dirty, or this has been used, or whatever, it's ripped, it goes in the bin. And they've got a take-back model. So they take that stuff, they'll launder it where it can be laundered. Again, they take the responsibility for tracking that. They repair it. I'll talk a little bit about what they've done to make it more repairable, where it can be repaired. Or they provide an end-of-life solution. And what is really interesting about this particular business model is that actually, because they're effectively using and supplying less stuff, that the price you pay as a service is not very different to what you were paying before for all the PPE you were buying. But actually, you're getting through less stuff, because less is just going in the bin or up a chimney, more is getting reused, and it extends. But that opportunity, that sort of extra money, is what then provides the capital to be able to build in the recycling infrastructure. Now, this obviously works a lot better on premium garments. And again, so a high-vis vest, not very valuable, not much to it, but those over jackets and over trousers, they can be £250 plus each. Because again, they've got very high standards, chemical splash resistance, etc. So those garments, high in polyester, are very cost effective to be able to offer this recycling opportunity to, or this supply model to. And the two balance each other out. It becomes a very attractive financial proposition to be able to outsource this service of providing safety to your workers in the form of high-vis and protective equipment, and also the management that goes with that. We've also done some work with Stuff for Life and ARCO on looking at redesign to enable that. Now, some of that redesign is to make it more repairable or to make it easier to track how many times it's been washed, if it's losing colour depth, that sort of thing. But some of it is also to make it easier for the next part of the process, which is when we look to recycle it. And so the final part of the process is that ARCO and Stuff for Life are committing to closing that loop. So you buy into that service model, and if it can't be laundered and it can't be repaired, then it won't go to landfill. They're going to reprocess it and supply it back. So what does that look like? Let's have a better look at that. It's a pretty simple process. As with most depolymerization processes, the technology is not particularly shiny. I shan't break it all down for you. But it's a standard hydrolysis depolymerization. They depolymerize it into terephthalic acid and ethylene glycol. They were then working with DuPont Teijin film to repolymerize it, and then Oxford fine cottons and others to turn it back into fabric and back into garments, the full life cycle. So it's as easy as that, isn't it? I'm sure everybody in this room knows that's the road. You just depolymerize it. And I see graphics all the time in papers that look something like this, that says you recycle it, you purify it, then you remanufacture it. Or you use it, then you depolymerize it, then you remanufacture it, and you just go round the loop again. And in terms of depolymerizing, I mean, that's really easy. Whether you do it in the lab or do it in a larger reactor, we've been doing it at CPI, we've been doing it in our site as well. Depolymerizing things is relatively easy, but I'm sure you all know that that's probably not the reality that you're going to see. I think it looks a bit more like this. You use it, and then I've said you chemically recycle it, because mechanical recycling is different here. But if you're chemically recycling, and that doesn't just have to be depolymerization, I think this is true when you're doing metal extraction from minerals and things like that. These processes that are extractive in nature, I think you chemically recycle, and then you get something where my clicker stops working. There we go, it's alive again. Something like this. Rather spoiled the thunder there, didn't it? I was working to a crescendo, never mind. Does something like this, just a proliferation of stuff comes out. If only it was, I had this, then I made that, and then it came back round again. In reality, you get loads of stuff. And when we look at the trade in a few minutes, this is the challenge, I think, that is the most significant challenge to some of the chemical recycling that we've been doing. Let's see if this is going to wake up again. This is tagged out. This is also tagged out. This is also tagged out. We just click next. So let me just give you some examples of what that looks like. So in the case of those high-vis jackets, one of the things that we can also get out is these microspheres. Now, you see, the thing about this proliferation of stuff that just comes out of recycling is it could be good or bad. Sometimes it's a great opportunity. So the polyester that high-vis is made of, in terms of the price of the garment, is pretty low. The fillers, the pigments, because they're very specialist pigments, are much more valuable. And those reflective strips that you get on high-vis, they're quite valuable as well, because they're full of glass microspheres or microprisms. That's what makes it reflective. They're pretty easy to filter out. The Stuff for Life process is deliberately a particular format so that they're not degraded. We can extract those, they can be recombined and reintroduced. So there are really great opportunities from that proliferation of stuff that comes out But for it to truly be circular and for us to really close the loop isn't just about just getting the polyester out, because actually plastic products in particular, just made of plastic, are not only rare, but often not the best performing. Adding fillers, colorants, etc., UV stabilizers, flame stabilizers, heat stabilizers, etc., is essential to their performance, essential to them being able to do what they do. Often I think of polymers much more as carriers of properties rather than the product themselves. Often it's that we're dosing something into a polymer for it to do whatever it's supposed to do. In the case of workwear, we're dosing in fluorescence, we're dosing in reflectivity. But, that high-vis vest isn't keeping anybody warm. It's not what it's there for. It's really just there as a carrier of other properties. Another one that you see, going slightly off this narrative, is you see it in pyrolysis as well. Any of you who've been involved in pyrolysis, you get this exact same proliferation of stuff that comes out. So let's say you're doing HDPE pyrolysis. This is from one of our papers where we were targeting trying to generate waxes. That particular data isn't from our paper, but the graphic is. We were doing a paper looking at targeting the generation of waxes. But you still get some light fractions. But when you're doing pyrolysis, you can easily get anything between 1 and 30% char, particularly if you're starting to blend in bio, which is very in vogue these days, because if you add 30% bio feedstocks to your plastic pyrolysis, you can count the whole output as bio-derived. Seems a bit dodgy, but you can. So you're running your pyrolysis. It's fine. Oh, that's fine. Thanks very much.
No worries.
So you're running your pyrolysis. You know what you want to get out. Usually light oils, sometimes waxes or whatever. In biopyrolysis, the char's pretty useful. In plastic pyrolysis, pretty dangerous. And at 1%, you can largely handle it. But when you're starting to talk about maybe a 15% amount of char coming from plastic pyrolysis, we work with companies all over the world, actually. We had this project Charnival. I don't know who made up these titles. This project Charnival, looking at pyrolysis chars. We had chars from all over the world. And it is the number one financial liability to many of these plants. Because if you're generating 10% waste char, that even in a country like India is over £100 a tonne to get rid of, that's a massive financial liability, and it's just taken away from your profit. And you can't just store it up, that's illegal. So you've got to have some way of trying to valorise it. And in other things, should we try that?
You might have to exit the slideshow, sorry.
Yeah, that's fine, yeah. Turn it off and on again.
Yep. If I blank this for you, just so,
that's fine.
just so you can, so if you exit PowerPoint and go back in, then let's check for you it works. Is that in PowerPoint view? Or?
Well, I don't know. It was.
It was. Sorry about this.
That's fine.
Turn this off blank.
You wouldn't have thought I could break a computer, would you? I literally didn't touch it.
No, I think it's the link has gone.
That's all right, I'll just keep clicking next.
Why is it doing that?
I don't know, that's a new...
Yeah, that's a new on me as well. Hang on, I'm getting there. Swap. If it's not clicking, you've at least got the laser here. So why it's not working, I'm not sure.
That's fine, I'll just keep clicking next.
And then there's a laser on the top.
Yeah,
yep.
Thanks very much.
Okay,
Thank you. No, that's absolutely fine. Sorry, everybody. Where was I? Yeah, so char. So with biochar, you can turn it into fuel briquettes, you can put it in as an additive, absorbents, all sorts of pretty established things within biopyrolysis. You try and do the same with plastic pyrolysis, and it's got titanium dioxide in there from fillers, got some very questionable benzene components that just sort of get lodged in there. Most of the char comes out in many processes still mixed in with the wax, so then you've contaminated your wax. So again, this proliferation of stuff that comes out makes it much more challenging to valorise it and really close that circular loop than it would have been otherwise. But like I say, can be good, can be bad. Oh, I'm still clicking. Just one final example just to illustrate this proliferation. This is one related to minerals. This is a project led by this company, Materials Evolution. And there are three aspects to the project as a whole. One focusing on the generation of sustainable cements, one looking at metal recovery, and the final looking at CO2 sequestration capacity of historic steel slag wastes. And there are millions, in fact in Teesside alone there's 60 million metric tons of just one kind of steel slag waste. The opportunity for zinc extraction, massive. The opportunity for cementitious materials, brilliant. But any one of those in and of themselves is really tricky because the byproduct you get is a nightmare. So you extract a lot of the silicates and aluminates and calciums for sustainable cementitious materials, and you get left with a mixture of zinc and tungsten and calcium and all sorts of other questionable things that are, to be honest, just some petroleum products from the fact it used to be a chemical site. It's very difficult to deal with then. So maybe then we try pre-processing it, and we extract some of the metals earlier, and then we turn it into a cementitious material, but then we turn it into a slurry, and you've got to dry it again. Okay, so, and you're constantly playing this balancing act, because in any, not just from waste-based feedstocks, but even when you're closing the loop and you're controlling your input. Lots of people at the moment are trying to define their input by saying, well, we make this product and we'll only take this product back. There are sort of two camps here, I suppose. There's having your own bespoke product that you only recycle, or there's businesses that deal with what I think of as sins of the past. Stuff that we've done is in flight and difficult to separate. Both are very valid, but both of them, if you've got fillers and other additives in there, still ultimately come across this problem of this proliferation, this development of multiple strands of outputs. So, NZIIC, who Abby's here today, and Durham University were looking at this a little bit, particularly in relation to plastic recycling, which starts part of this, and I'll show you that work in just a second. But I want to show you the work of NZIIC and Durham just very quickly, just to illustrate what they were doing. They started a piece of work mapping that supply chain, mapping the recycling of the main feedstock, but also some of those side feedstocks. Now this is just for the Teesside region. I'll show you the tool that we developed on the back of it, but just to show you, this is just in the Teesside region. We mapped 34 recyclers, 28 waste suppliers, and a number of supportive infrastructure type businesses as well that went round this supply chain piece. And this is the tool which will launch in June at the NZIIC Clean Growth Conference. Again, if you want to find out more about that, Abby, where have you gone? Give it as she is. Give us a little wave. Chat to Abby about that. This is an amazing tool. We've helped NZIIC to digitalize this and turn it into an interactive tool which will be published. And what you can do is you can sort by company, but you can also sort by feedstock. So you can click on PET, identify the mechanical processors and processors available within the Teesside supply chain. You can identify those which turn into food grade, non-food grade, those that have primary or secondary chemical processes, and the end of life for some of those different streams. So you can begin to find out where in that supply chain for those different kind of products they exist, and we're expanding that now to cover more. One of the most amazing things about the Teesside Industrial Cluster is it used to be part of what was ICI, which was a very large chemical company. But what it means is that there's huge connectivity. So shared, on a private wire network, shared steam, shared hydrogen even, there's hydrogen pipeline existing, lots of shared resources across the site, which just facilitates great industrial symbiosis. And actually also facilitates quite a lot of, at business level, collaboration and symbiosis of those businesses and the way they think and work. Which is a great environment to start to look at this sort of stuff, because they're already in the mindset of sharing. They have the infrastructure to share. They're very keen to share because it's very financially viable. So being able to understand the new green circular opportunities, particularly for inward investment, this has been hugely valuable. Because we're able to say to a lithium processor or someone who comes in, you've got this offtake of whatever it may be, calcium or some other mineral deposit. Here's some of the people who might be interested in taking that off you. Would you like us to facilitate some conversations about what an offtake stream for that might look like and integrating that into a supply chain? The same around polymers. When people are looking to set up some of these recycling processes, take Renew ELP for example. On the front of their process, even though it's come out the back of the Biffa process, a really good sorter, they have another sorter to make sure that what goes into that process is really clean so that they can get the quality they want out the back end. but then again, you then need further off-takers for the stuff that you don't want. And you just keep moving that cycle forward. And so this supply chain piece is really useful. So this will be really exciting when it's released in June. I'll click next again. And then the work that NZIIC and Durham did on the back of this really then went on to look then at, well, what are some of the opportunities and challenges that are related to that idea of, okay, well, I want to find end of life for all of those flows, all of those different bits that come out. And what became very clear is that where there was established processes for commodity polymers, what we call in the top right-hand corner, these coordinated ones, that really you're focusing on cost reduction. These are well-known, usually mechanical processes, where you're really trying to drive efficiencies into the process. Where you're starting to use newer technologies, we're really trying to develop improvements in purity, improvements in throughput, improvements in degradation or application or overall cost of the product, as opposed to the virgin higher value, though with the price of recycler at the moment, that's very difficult. Or you might be looking to ramp up or have something specifically customized. And they extracted from this a whole number of opportunities and challenges. I just want to highlight a couple of these to you today, because I just think these are really informative, again, as we look into the rest of today and some of the speakers who are coming after me. These illustrate many of the challenges I think that people in this centre have been addressing. Things like capacity, where you've got really good feedstocks, but they're not large enough to have scaled industrial processes that are really cost effective. Or this constant challenge of the cost efficiency of running these recycling processes versus virgin feedstocks. At the moment, really challenging, because recycled material is so valuable. You can charge such a premium for particularly mechanically recycled, but oil feedstocks are so variable in price and so fluctuate so widely that it's a very volatile market. And so that you end up with a very large risk register when you start trading in that nature. Viable today, 5 years' time, might not be. You're very subject to international trade conditions, things like that. The new development of new technologies is providing us loads of incredible opportunities, technologically and in terms of new material feedstocks. But again, securing those feedstocks now is becoming a huge limitation, because just because you can recycle it doesn't mean you can get hold of it. Or not in a volume, again, that becomes cost effective and you want to scale to. So there's a whole number of these challenges that, again, we're really interested in really delving into within that supply chain model as we spread that out across the Tees Valley region and ultimately beyond, to understand, well, what are the thresholds for some of this? What does success really look like? And that's where we've really moved into this final stage of looking at supply, as we continue to work around that wheel, around trading it. I don't know how much you're aware of this bill that's going through Parliament at the moment, the Electronic Trade Documents Bill. I was just going to say it's really interesting. I probably oversold it a bit if I say that. It's quite significant, we'll go with that. The Electronic Trade Documents Bill will basically mean that we can use digital documents to enable trade processes. Now, it doesn't sound very interesting, but the way we do trade at the moment is based on laws that were developed around the same time as Napoleon. If you want to export something, many of you won't have been involved in export, I have. It's about 64 documents, some of them email, some of them paper-based. If you're at a free port, we've got a free port in Teesside, one of the things you have to do to change goods trade status from being international to being on UK soil is you have to move it. So you move it from one car park with a fence around it using a crane to a different car park with a fence around it, and that's how you know its trade status has changed. That's really hard with chemical goods. That's really hard with polymers because of this proliferation of processes. People are looking at this, particularly around critical minerals. I know that there's work going on within the centre around EV battery materials and lithium extraction. And that's really important because it has the same problem. You're looking for lithium, but you found hafnium and rubidium and whatever else as a byproduct. Now I've got to track that as well, otherwise I can't sell it because I've got to be ESG compliant and no one will take it off my hands, etc., etc. These are really complex processes. The same with, if you want to be, so ESG compliance is to do with the environmental and social impacts of what you're doing. If I want to sell my recycled product back to DuPont Pigeon Film, for them to reintegrate and send back around, the customers who are buying it at the end, they want traceability that it really is circular. One of the challenges we've got is, over the years, there's been so many recycling schemes, one just went bust recently, hasn't there, that have just been dishonest or just been hoarding waste and stashing it away and saying they were selling credits, but were actually just sticking it in a warehouse and hoping the problem would go away. That now people really want that traceability of where that stuff's gone, where it's come from. And that's really difficult when you're not just tracking one thing. Again, it sounds great, I used my garment, then I remanufactured it, then I made a new one. That would be easy to trace. That's what happens in automotive supply chains. You build something, you bolt another bit on, it goes into the car, you traced it. Fine. Depolymerization is, I had a garment, I shredded that garment and lost 10% of it, and then I depolymerized it. I only recovered 70% of this, and so the rest of it's gone somewhere and I'm not quite sure. Very hard to explain that to your shareholders. So this is one of our key challenges. And we're working with the Digital Catapult and the Centre for Digital Trade and Innovation, which is part of the ICC, the International Chamber of Commerce, to look at how we can utilise this new law, will be legal in the UK, it's already come into place in other countries as well. They've got it in Singapore, they've got it in Thailand, many other countries are developing similar legal frameworks to enable digital trade documents. What are the opportunities this poses for us to become more transparent, more honest, to really enable circular systems and to design them in at the outset? What we're really keen is, all these documents do is say, well, you can, but they don't tell you how. They don't define the mechanisms by which it has to work. They provide some things you have to do to enable things to get onto UK soil or to track. But they don't say what ESG compliance has to look like. They don't say how it has to work. They don't say what platform it has to be done on. This is an incredible opportunity for us to build in circular economy principles into the design of those processes, so that as these business models become more and more viable and we see increasing amounts of this activity, it's within the trade specifications. At the moment, it's really hard to run a circular business because it doesn't fit within the trade flows. It doesn't fit the standard paperwork. Particularly if you want to run a circular business model across borders, very difficult to provide that traceability, and you end up having to break everything down as an individual product category. It can be a real barrier. So there's a great opportunity for us to build in something. And so we're working on two specific aspects of this within our centre. And the first is to do with data collaboration. Ways of sharing data, or ways of sharing confidence in ESG compliance or source of origin or whatever it may be, that enables people to see that data or feel confident in that data, maybe without sharing the data itself, to be able to underpin those trade documents that we need to sign off that inform techno-legal processes, economic processes, finance processes, etc., etc. And the other area we're interested in is physical assurance of trade processes. Again, this is tricky. This is what I was talking about earlier when I was saying you have to move a container from this box to that box. That's the physical assurance. The way we do it at the moment is you physically move the box. Well, that's never going to be efficient. We can do that using geofences and things like that. We can change a consignment sort of definition, its trade definition digitally. But if we do that, one of the things that's clear in all of the international regulations is you're going to have to prove it. You have to have some physical assurance. Not just, I flipped the switch and then now it's okay. But how do I know what's in that box, what it says in that box? How do I know that this material that came out with DRC is really what you're saying is coming out there? How are you going to provide that sampling? Great example in polymers is if you take a mass balance approach and you decide, well, I'm going to take my polyester plant, I'm going to directly inject hot bottle flake into the side of it to increase my recycled content, my virgin material, nice and straightforward. Straight mass balance approach, very, very easy, well, relatively easy to do. It's very easy to do, I haven't got to do it, but technologically pretty easy to do. But how do you then provide confidence in the amount of recovery and prove the amount of mass balance that you're actually transporting to your customers? Simple mass balance just says, well, that's got 20 tonnes in, so I've got 20 tonnes out. It doesn't quite work like that then, does it? And that works on, hot wash, really nice bottle plate. You want to take some of the materials I've been showing you today. It's never like that. And then you want to take waste-derived feedstocks, and you know that they're not pure, so it's even less like that. And all of a sudden you realise that if you want to be really traceable, really transparent, and have honest ESG data, just a mass balance approach alone isn't enough. You've got to have some way of physically assuring what's going in, what's coming out. So one of the things that the Digital Catapult have been working on, and I think this is really interesting, so I'll just show you this very quickly, is this whole idea of at all sorts of different points in the process we collect data. Physical data, real data, observation, trade change data. And there are multiple platforms that hold that data, most of whom are in competition with each other, which is, a bit of a challenge. This is the classic interoperability challenge. We get exactly the same in the chemical sector, don't we, where large companies don't necessarily want to share their inner workings with each other, makes trade challenging sometimes. But that's just the commercial world we live in. So we need some way of them working together. We need some form of insight environment where you can collaborate, you can share ESG data, you can get finance confidence for sign-off and things. You can get confident that something is what it says it is without having to test every stage in the process. How can we get confidence in people's data? How can we build that in? How can we build in these circular economy principles into these models? And this sort of a tool is really important to that. So, just to go back to my wheel, this was the Stuff for Life wheel I showed you originally, where they were starting with this use and return enabled by a business model. I continue to think that for chemical recycling of polymers, the business model is the most important thing. Because unless you can get that sustainable supply of feedstock, where you're getting the quality that you expect to get on an ongoing basis, because the classic story is someone supplied me the feedstock I was expecting, and then over a year, slowly and gradually and silently, change that feedstock to be a little bit worse, and a little bit worse, and a little bit worse, and wait until you notice and then go, oh, sorry, I'll dial it back a bit. To find out what I know you said you wanted it super pure, but isn't, kind of pure good enough? It's really difficult, because then you think, I just don't understand why my efficiencies keep dropping off. Oh, because if you don't own your supply chain, you can't control your supply chain, or they can't get that supply anymore in this competitive recycled environment. It's very difficult. So I continue to believe that the business model is absolutely key. And when we hear from the SMEs later, really interested to hear about how they're working with that supply chain across all sectors. The reprocessing and manufacturing, in my mind, is often the easy bit. I know that some materials are hard to break down, but actually, in the grand scheme of things, developing the right business model and developing a techno-economic framework that allows you to actually buy and sell it, I think is much more difficult. Now, that might just be because it's not my specialist area, and I'm just sort of, stretching my brain. But actually, I think it's because there are just so many more barriers. The idea of trading something that you don't own, that you don't necessarily have that ownership or that confidence over, is much more challenging than, you give me a load of material and ask me to break it down. Probably quite possible. Doing something with it, that's another story altogether. Making it economically viable is much more challenging. That's why I find that this pretty simplistic wheel to be quite helpful in my own thinking, because it tells this story of the business model, the reprocessing, and then ultimately the need to resupply it, either back to the same manufacturer or to somebody else. But the fact that there's a whole supply chain needed for that, it's not a single supply chain, it's a multiple supply chain, it's a dynamic supply chain. You need multiple suppliers for resilience. And that, for me, is the journey of non-mechanical recycling. And with that, I'll take some questions, if that's okay.